Please, everybody stand up. So, hi, this is me. I'm Jacob Burkhart. That's me when my legs do work, catching waves. You can follow this talk on GitHub. It's slideshow talk, or show-off talk. And that's my Twitter handle if you want to tweet at me while I'm talking to you. So really, I want to start with setting the stage that I don't really know what I'm talking about. Like, what do I know, really? So last time I gave a talk, I talked about surfing. And I gave all sorts of life advice about how you should live your life and be a great person and be a surfer. And I'm going to do the same thing now, except I'm going to talk about how you should be a developer in a distributed system and do service-oriented architecture. And that's really just based on my experiences at Engine Yard building the Add-ons program. So listen to what I say, but please just be inspired by what I'm saying, not necessarily think that I'm telling you everything. So Engine Yard, like I said, I work there. We're like a train in the clouds deploying your Ruby and PHP applications. Thank you for Engine Yard for sending me here. So what I wanted to give you a story about is the Engine Yard add-ons program. So if you have an Engine Yard account, you can go to /add-ons or navigate there, and you'll see this page. And you can just click on one of these add-ons and turn it on and follow the instructions. And a few steps later, you'll be connecting to a MongoHQ database or sending emails through SendGrid. So I want to talk about the story of building this system. So the first thing you do with anything, regardless of what we're talking about, is write documentation. So in the case of the add-ons program, we wrote the documentation not only to document the code we're about to write, but to talk to the partners that we're going to write these add-ons and figure out if we were hitting the right use cases, if what we were thinking about doing was going to make sense. So the API goes through a lot of use cases and things, and then it actually has code examples of if you use our service, we propose to return these values and have it behave this way, right? And this was totally not even implemented, and we knew it was going to get changed and thrown away or whatever, but it was important that we had this document from the start and that we kept it up to date and maintained it. So this is a sort of diagram of some of the things that are at Engine Yard. Service-oriented architecture. Question by the way for the audience, how many people here work on a Rails app that is more than one app? That they have to communicate between two apps generally. It's not just one app. Okay, that's a decent number. So yeah, at Engine Yard it's 12 or 15 or 20. I want to focus in on these three. So this is Cloud Dashboard was the big guy in the middle. That's our sort of legacy monolithic, everything goes in that app. And then we've as we've added features, or as we've had the opportunity to, we've extracted things out and built things as new systems. So when we were developing the add-ons program, this could be 2 boxes instead of 3, right? We could have drawn a line directly from all of the third-party add-ons into the Cloud Dashboard and not bothered with this third system. So why did we do this? Why did we add this other box? So the main reason, one of the main reasons was to minimize the changes that we had to make to Cloud Dashboard. So this being a giant application, it takes a really long time to run the tests. You have this risk of when you deploy it, it takes a long time to build, and so you want to be able to iterate really quickly, deploy the add-on system, and if it breaks, not have to worry about it breaking the main system. But more importantly, the real software architecture reason is because it forces us to decouple things, right? The add-on system really has very little to do with all of the other things that the Cloud Dashboard does, right? The add-on system doesn't need to know anything about booting instances, for example. So it really does belong in a different place. And by putting it there, we're actually forcing ourselves to write code that's more decoupled, because we have to talk over HTTP instead of Ruby. I'm just going to read this. Every piece of knowledge must have a single, unambiguous, authoritative representation within a system. Does anybody know what this comes from? Have you seen this before? No? Come on, you're shaking your head. Just say it. What is it? What is it, Constantine? It's dry. Have you heard of dry? Do not repeat yourself. So I like it written out like this because this applies to distributed systems as well, right? And do not repeat yourself means do not store your data in the same, like don't duplicate your data across systems, right? So in a distributed system, dry means that you're figuring out how to distribute your data and distribute your objects. So here's a very basic example. Well, not example. This is just a basic version of the data model that we had with the Add-ons program, right? So in the middle, the Add-ons program knows about services, and it knows about services that are connected to accounts. But it doesn't have all the information about an account, right? That belongs in the dashboard. And then over on the end there, the service itself doesn't have all the information about the account. It just has its own view of some account that's attached to a service. I'm just going to skip this one. So here's a code example. We have an active record object that is the service, right? That's actually in the database. And then we have this API struct object, which is some other service might reference it that way, right? So it's both systems reference this object, but only one system is actually storing it. The other system is consuming it. And here's the actual diagram of all the objects as they're related in our system. So I thought this was important to diagram all this stuff and sort of figure out all the relationships of the data that we were going to have ahead of time before we started developing this system, right? And obviously, I got it wrong, and we went back and made changes. And so that was sort of part of our documentation. Like, you would do this traditionally with, like, you like draw a diagram of your database schema, right? That it's more important when you might have to move your table across to another system to know ahead of time. So all these distributed objects, how do they talk to each other? They talk to each other with APIs. So I'm going to take this diagram of these three systems, and we're going to draw it again to look like this. So the name client and server are kind of arbitrary distinctions here, but since it's the add-on system, I'm going to call the add-on system the server. And we're going to have a private API that the dashboard uses to talk to the add-on system. And we're going to have a public API that third-party services have to use to talk to our add-on system. And then we're going to have these workflows whereby when you do something, that's going to trigger a call to an API, which is going to trigger something to get saved in a database. It's going to trigger a call to another API. That's going to get a response. That's going to save that in the database. That's going to trigger the response to the original API call. That's then going to result in something actually working for the customer. So given that we have that sort of complicated design, we've made life harder on ourselves by sticking this service in between. Where do we start, right? We have some complexity to deal with. So regardless of distributed systems, whenever you have complexity, here's some things you can do to deal with the complexity. One of those things is iteration, right? You can solve a small subset or one use case of what you're trying to accomplish, right? We didn't implement all of the add-on system at once. We try to pick like a very minimal use case, like I just want to be able to see a list of services, right? Maybe I can't enable them yet, but just one thing, and then add on to that. And the other thing that's similar to that is isolation. So isolation means take something and don't test the whole workflow. Test something by itself and test that it works by itself. And then once you have several little things that work by themselves, you can connect them up. So we took this diagram, the thing we wanted to build, and we changed it to this. So the first, to isolate, to implement our first thing, we're gonna just do this enable service call, and we're gonna mock out everything else that's happening, right? And when I say mock out, you'll hear Shai talk about lots of different ways that you can mock things out in the talk later that he's going to give. But when I say mock out, I mean mock in the way that the API client provides a mocked mode. How many of you are familiar with this concept? That if you're consuming an API client, you shouldn't have to write the mocks. That should come with the API client. I got this concept from Wes. Anybody know Wes? Wes worked in Engine Yard, and he worked on this project called Fog. So I want to give a little demo of Fog just so you get a really good concept of what a mock mode is. So you guys still hearing? So Fog is a library for talking to Amazon Web Services. It's for doing a lot of other things too, but I'm just going to grab this code here. I'm going to put it in my terminal. And don't worry about what that says. I just set up a Fog object. The real important thing here is that I can go fog.servers, and that's going to make a request to Amazon to give me a list of all the servers that are running. And since my Wi-Fi doesn't work, we get a socket error of no server name provided. But Fog ships with the mock mode. So I can say fog.mock and then create a new instance of Fog. Right? And now when I do fog.servers, I get an empty array. So that's hitting the internal Fog mocks. And we use this a lot at Engine Yard because we talk to Amazon and we want to write tests. And we don't want to spin up an instance every time we test what happens when a customer clicks a button to boot an instance, right? We want to hit some mock backend and be assured that that's going to behave like the real thing. So just to do one more thing, I'm going to do fog.servers.create. And it actually like creates this thing like there's a server. And now when I ask how many servers there are, it says there's this array of one object and so forth, right? So you interact with it and it persists and it acts like the real thing. So in building the API system, or the add-on system, we knew we wanted to have mock modes for our clients. So far, we'll review. Document our use cases, distribute a data model, identify our APIs, iterate, pick a very small use case to start with, and then isolate different things using mock modes. So how do you guys think of this approach? Sound good? Sound like we're ready to write code? So we wrote some code. We wrote the private API client, only implementing a little subset of it, but we wrote it. We wrote a mock mode for it, and then we used that mock mode to write some code in the cloud dashboard. And then we wrote our public API client, and we wrote a mock mode for it, and we used that mock mode to write the fake service. And then we wrote the add-on service, and we implemented those few bits of things that the public API and private API client needed. And then we wrote all these tests, and these tests were running in different systems, and they all passed, and they're all green. And that was great, so we deployed. And we got this, this lovely message from our system. Anybody know what went wrong? What I do wrong? What the error really was? No, wait, we didn't know. We didn't know what the error was. So the problem was it was confounded by, so I would go and look at the error log, right? So this is the error I see on the cloud dashboard. And it would say, oh, the 500 error, and then I look at the exception, and it's like, oh, I got a 500 error talking to the add-on system. So I would go look at the add-on system, and I look at its error logs, and it said, oh, I got a 500 error talking to this other service. And I have to go look at that service, and they're like, oh, I expected this parameter. So debugging this stuff is very hard, right? Because you have 3 separate systems. So the real problem was that we had difficult time understanding all the interactions in the system that we built, right? We had documented really well the use cases that we wanted to support, and we documented the API that we're going to provide to third-party services, but we hadn't really understood all of the interactions and how the data would flow through these systems. And finally, we didn't have any integration tests, right? I talked about developing with mock modes, but I never talked about verifying my mock mode or integrating the full thing with like an end-to-end test. And full integration tests are really hard. So the obvious thing you might be saying to like, oh, well, how would you test this now, is you'd have to spin up a full version of our cloud dashboard and spin up the full version of the add-ons system and then spin up a full version of the example service and then have some test harness that coordinates that all and send some requests here and do all these steps and go through it, right? So I was struggling with this problem, and I talked to Tim. Tim was my coworker, and we pair program a lot at Engine Yard. I recommend it. And so I showed Tim my problems, and he was like, that's craziness. Write a spike. Who knows what a spike is? Spikes. Constantine knows all the answers. It's this spiky thing on the bottom of the ocean. No. So the idea of a spike is that it's throwaway code. So whenever you have a problem that you're trying to do it the right way, and you're running into so many obstacles, and you realize that you don't understand the problem well enough, a spike is a good solution. A spike says, I don't care about TDD for now. I don't care about really good maintainable code. I care about writing something that works so that I get a better understanding of the problem, right? And the hope is that after you understand the problem, you'll be able to throw away your spike and write really good code. And in my case, what I needed to spike out was what the full integration looked like. So here's a little demo of my spike in action. So my spike was actually 3 apps. I made a fake version of the Cloud Dashboard app, right? Instead of integrating with the one that our customers use, I made this terrible UI that all it does is you say click boot a cluster, and it doesn't actually boot a cluster. It just says, OK, I did, right? And so then I booted these 3 guys up, and you could do interactions where I would like copy stuff from one app and put it in another. And so here you can see I'm going to register a service from the example service, and then I'm going to go back over to the add-on system, and it's going to see that it came through, right? And so by doing this way, I was in much more constrained environment that I could iterate faster and understand the problem, right? I'm just going to skip forward. So then something happened. So I got my spike working, and it figured out that I could actually write a test for my spike. So all the interactions that I was doing when I was demoing this to my coworkers about, oh, here's how it's going to work, I could write a test that would automate those steps, right? And it's still kind of fuzzy work here because this is throwaway code, supposedly, right? But we set up Capybara is a good way to test web apps. So we set up Capybara to say, talk to all 3 of these guys. Like, this is my Rails app here, right? Add-on service application. But then these guys are just my fake servers. And then I'm going to write these tests that say, well, visit this URL, click this button, copy this data over, paste it here, click this button, right? And so now I was automating everything that my spike was doing. So somehow we have to transform this into workable code, right? So we wrote a few good integration tests. Integration tests are like surfboards. You need some variable ones. They need to be really long, but you don't need a lot. So we wrote these integration tests, and having them allowed us to write our real code. They drove our real code. So we would take one integration test, and we would start replacing part of this spike we had written with something real, right? And we would fill that role in with the real API client, the real API server. And then we would write real tests for that code, right? We wouldn't rely on the integration test to verify that. We would just rely on the integration test to make sure that we were still doing the same workflow, that one thing that we were trying to figure out with that interaction. And by the way, like the process of converting from a spike with integration tests to production code with TDD was actually a very long, strenuous, difficult process that I could spend the whole time just talking about that. But I think if you have these tools that I'm going to talk about later, and now, you'll be able to figure it out. So one of the things that we had to do then, at some point, was to verify our mocks. So we sort of converted some of our spikes into fake services to provide our mock modes. And then we wrote tests against those services. And we were able to run our tests in 2 modes. We run our tests in the real mode, where they use a different gem file to pull in different dependencies and actually pull in the real production system. Or they use the default gem file and they just run the fake. And this, 10 minutes, this validates things. And Shai's going to talk about more. And then, actually, this is what it really looked like, which is all really complicated and confusing. But just to say that it's not as simple as I'm saying. So, OK, we did all that. We figured out a way to write code. So it's time to ship, right? Yeah. No, we shipped. We shipped and we didn't have anything done yet, right? We were still developing. None of it worked, right? But we had like one feature, which is like list services. And it's OK to ship when you're not done, because we have feature flags. So our accounts have this relationship to many features, and they have this method called hasFeature. And then in our views, we just say, if you have the feature, show stuff. And if you don't have the feature, we're not going to show it. And so we just don't turn the feature on except for like a few accounts that we're testing on, or for staff accounts or something, right? And so that way we're able to get out into production, and we'll feel a lot better about ourselves. So after we were iterating for a while and shipping, and our partners started to work with the system, we discovered that it would be really useful, and it ended up being really useful, to actually share our exceptions. You shouldn't do this. You should use an exception tracker. But getting 20 different other people that you're working with that are in other companies to have login credentials to your exception tracker was annoying, so we just built our own inside of our add-on system. And it just showed the 5 most recent errors. And it really cut down on the email volume of like figuring out what's going on, and it let people integrating with our API sort of have that first step of try to figure it out myself, like what the error is. And oftentimes it was our own bug, but they were able to tell us how they triggered it, and we were able to fix it faster. Here's a specific view of a specific exception, and one of the things I want to point about this is an exception where the response status was 200. So you might think that exceptions are only 500s, right? But when you have this system of client talk to server, talk to somebody else, right? You have the request, the server handles the request and sends the response, and then the client has to do something with that response, right? And if the server sends a response that the client can't handle or doesn't handle correctly, the client will have an exception, and the server won't know about it, right? So it was important for people developing these services to be able to see exceptions that we had handling their responses. And there was no way in the HTTP protocol for us to like post back and tell them about it, right? They had to come and see. So here we had an error parsing the JSON response they gave us. Okay, so that's the end of my story. Any questions about my story? I'm going to talk about some tools. And when I mean tools, mostly I mean Rack. So Rack is the magic that runs Ruby web applications. It connects your Rails app to your Mongrel or your Unicorn or your tests, even Rack test. So I'm going to talk about a lot of Rack tools. So the first is to just show you a minimal Rack app. I have 10 minutes. Maybe I shouldn't actually. So a minimal Rack app responds to call. And fortunately, Lambdas respond to call too. So you can actually write a Rack app that just returns this array of response status, headers, and a body that responds to each, right? Sinatra is a Rack app too, right? So here's a minimal Sinatra app that responds to get requests at /hi and returns a body. And we can't just call it because it's going to try to do routing and stuff, so we have to pass a few of the standard Rack headers, like the request method and the path that the request is made to, and this IO object, right? And you can even write a Rails app that fits on one slide. And Rails is a Rack app, so here you can copy this code and try it at home and make a request with call, and you'll get the hi controller routed at / to say hello. And so one of the tools that we used when we were going from Spike to integration test was Artifice. So normally, when you use an HTTP client, you're probably going to use an HTTP. And so here's an example of using an HTTP, and it'll actually go to Google and print out the response of the page. If you were to call Artifice activate with any Rack app you want, for example, your Rails app, and then make that an HTTP request, you would get the Rails app responding at that request, right? So this is a tool that we used in tests to sort of like override everything so that when any client was like making a request somewhere, we could route it to the right place, right? And then you have to deactivate when you're done. Activate with Capybara. But really, you shouldn't use Artifice. You should use Rack Client. Rack Client is a HTTP client that has pluggable backends. So the default backend is an HTTP, but in this example, you can see that we've changed the backend to be our Rails app. And so this has the same behavior of redirecting that request that was meant for the web to go to a particular Rack app that's in our memory space, right? And Rack Client has the advantage of I can do that per client instead of just overriding it globally like Artifice did. Rack Map, which is sort of a fundamental thing about Rack, lets you take multiple Rack apps and put them together, right? So you probably use Rails routing, but Rack has routing too, and it's called Map. And this is what we used in our integration test to take those 3 apps and map them all to different URL prefixes, and then say rack client point to that, and then it would route to the right rack app. And we don't have to worry about using anything else to do routing, right? Request visualizer. So this is something that I wrote in the process of doing this when I was, mostly because I was pairing with people and they didn't understand what was going on. And so I had to show them. And so I wrote this rack middleware that prints out the requests and the responses. And it has the neat feature of doing a little indentation when you make another request before you respond. So I would stick this into my integration test that did this long running things, and you would see the request and the response, and you would see these indentation increasing as requests were made and then responses came back. Only a few more tools. POW. Anybody use POW? POW is what I used when I was doing my spike so that I could run those 3 servers and have good host names for them, right? Like if you don't do that, you're just going to have localhost 3000 and localhost 4000 and localhost 5000, right? But POW sets up a proxy for you so you have like a nice something.dev name. But really, you shouldn't use POW. You should use a DNS hack called localdev.engineer.com, or you can make your own. Localdev.engineer.com points to 127.0.0.1. So anything you want, .localdev.engineer.com will point to your own computer. So what we ended up doing is rack map, mount everything in one app, and then depending on where the request comes in, it'll get routed for us to the right rack app, right? And I tried this myself on my own domain. You just have to do an A record star.localdev with a value, so you don't have to use localdev.engineer. Yeah, and here's that example. So this is what we use in development mode for some of our applications. So in development mode for some apps, you have this dependency to talk to other apps, right? And you might not want to have to spin up the other app. So instead, you spin up a mock version of that other app running on a different URL, but the same port number, right? And so that way, like the app can talk to itself or show you pages from the fake while you're doing things. Distributed code bases mean, or distributed systems mean oftentimes distributed code bases, right? You should have one app per code base. So this is a trick using bundler. This presentation is written using showoff, and I was making changes to showoff to make it support some of the things I was doing. And so I had my own fork of showoff. So I could edit my gem file and tell it to point to my fork. But when I was making lots of changes, I didn't want to have to keep pushing those changes up to GitHub and then refetching them, rebundling. So I can actually tell bundler to point to a path. And I would tell bundler to point to my own disk where I had my showoff checkout. And this is a tool I use when I'm doing development across multiple systems. If I'm going to actually make changes on all those systems at the same time, I can use bundler path, and then when I'm done, change it back to a Git repo after I pushed. What else? Am I out of time? Is that what you're saying? I'm not out of time. OK. A few more things. Your domain model should not match your database model. So this really short example is showing that I had a method for presenter, or a presenter method, which you should do. And so when I'm presenting a service, I'm not just saying service.toJSON and you get all the attributes. I'm actually composing something that's relevant for the person or for the system that's looking at this service, right? So it cares about if the service is enabled or not, because maybe this is from an account looking at a service, right? So there's no concept of a service existing more than once. Another big thing is that you should not use IDs. You should use URLs. So when you create a service in the add-on system, you don't get an ID, you get a URL. And you can get to that URL to get information about your service. And you can put to that URL to update your service. And you can delete to that URL to get rid of your service. And there's a different URL you can get to that gives you a list of services. And in that list, you get URLs for each thing, and then you make a get to those URLs and so forth, right? So by using URLs instead of IDs, you only need to know like 1 or 2 URLs as the base to accomplish everything else, right? And it's hard for us to change URLs in external systems, but in internal systems, this is really good because I can be providing something at some URL and then decide that I want to move that to some other service and start returning a different URL that points somewhere else. And as long as I'm maintaining that contract of like, this data is over here, I'm more flexible. Last tip, involve your designers early. This is some designers slacking off in a hot tub when they should have been looking at my spike and making it pretty. Because when they finally did look at my code in production, they were like, oh, we need to change this. And we need to show this other data. And that meant that I needed to fetch that other data. And that meant I needed to make sure that the third-party service was providing that data, right? And so the front-end design, when you have these connected systems, can really change a lot of the structure of your API and what kind of data you need to send. So understanding that up front is really valuable. That's it. Questions? I went through a lot of stuff.
So with those internal HTTP services, how do you deal with the fault? Do you put like a load balancer instead of each service and make sure you have 2 instances behind and so on, and to deal with the faults inside each of these small components?
Well, it's a good idea to have a load balancer anyway, right? I mean, generally when we deploy systems, we try to have the engineering concept is app master and app slave, right? So if one goes down, the other can pick up the slack. But more importantly, you should be fault tolerant to your systems going down and display something graceful, right? So actually, a trick that we did is that when we render the services page, we render the page and then make an AJAX request for the actual services. So that way, if that were to time out or to error, you at least still have your navigation or something, and you can like show like an inline error. Or like when we're showing information about services in the context of something else, right? We don't want to hold up the whole render of the page just to fetch that information. So we'll render the whole page, and that little block of information will fetch with an AJAX request. And if that times out, then services are down, but you can still use our main app, right? That's a good point. I should have talked about that too.
How do you handle the increased latencies to go to different services from one central access point if you have a server-to-server communication?
Yeah, it's slower. You have to make sure that you're doing things that, like, so, I mean, this is a good question, actually. So we were thinking about, like, you click the button to enable service, right? Should that happen in the background, or should you actually wait? You know, like if the add-on that you're trying to enable is running slowly, or has an error handling your request, we want that to come back to you and you see that, right? And we want to encourage our add-on providers to respond quickly. So I think in a lot of cases we could try to like background things, but we've taken the approach of don't background it until there's a good reason, right? And so far, we've been able to say, this is fast enough that this is like, it's more obvious to not do things in the background. But yeah, the obvious answer is, if something's going to be slow and you're going to have to talk to multiple services, and figure out a way that you can have a background job make that request, and then update some state, and then be able to show that later.
Okay, I think that's about it. Thank you very much, Jacob.